Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So in this video we are going to discuss about the isomerism. So this is for chapter 11.3, which is in introduction to the organic chemistry. So before we go further to discuss about the isomerism, so we need to look at the definition of the isomerism itself. So it is a compound or the organic compound with the same molecular formula but different structural formula. So what does it mean by molecular formula and the structural formula? So before we go further to discuss about the isomerism, let us recap about the term molecular formula and the structural formula. So we have three terms here. The first one is molecular formula. What does it mean by the molecular formula? So molecular formula is the formula that show the actual number of carbon and hydrogen or actual number of atom in a molecule. Let's say for pentane, for example, C5H12. So this is the molecular formula for pentane, C5H12. And the empirical formula is the simplest ratio of it. So for pentane, the empirical formula is also C5H12 because this is the simplest ratio. Let's say if we have C2H4, okay, the simplest ratio will become CH2. Okay, so kalau if we still discuss about the pentane, so the structural formula is the actual arrangement of atom in a molecule. So we can draw the structural formula like this. Let's say we can draw 1, 2, 3, 4, 5. It consists of 5 hydrogen carbon and 12 hydrogen. So in this case, we draw the structural formula in a form of expanded structure because we expand the bonding between each atom. We also can draw the structure in a form of condensed. 1, 2, 3, 4, 5. This is what we call a condensed structure. And we also can draw the structure in a form of skeletal. We have 5, 1 first carbon, second, third, fourth and fifth. This is skeletal. This is number 1, this is number 2, and this is number 3. So meaning that the structural formula can be represented in 3 different ways, either expanded, condensed or skeletal. Right? So this is the difference. So the isomerism relate to the structural formula and the molecular formula. Now let's look at this diagram. So the isomerism divided into two. The first one is structural or constitutional isomer, and the second one is the stereoisomer. So in this video, we are focusing on the structural or the constitutional isomer. So it is divided into 3, which is the chain isomer, positional isomer, and the functional group isomer. The chain isomer, normally the compound have the same chain but have a different change. Positional isomer, same change but different position of the functional group. And the functional group isomer is fixed, meaning that if you have an alcohol, the partner is ether. So maybe I can summarize it here. So alcohol, the partner is ether. If you have an aldehyde, the partner is ketone. If you have a carboxylic acid, the partner is ester. Okay, so you have to remember this because the functional group isomers is between this partner. Alright, now let's look at the first example. Let's say we have a molecule C4H9OH. So this molecule have one oxygen. So as I mentioned in my class, if you have one oxygen, there is a possibility to become an alcohol and ester, alcohol and ether, or carbox or aldehyde and ketone. So let's check. So we have two possibility, either alcohol ether or aldehyde ketone. So let us check. So 4, 1, 2, 3, 4. So we have one oxygen, maybe like this. So now let's count the number of carbon and hydrogen. So we have 4 carbon, carbon is enough. Hydrogen 9 plus 1, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1 oxygen. Meaning that we can conclude this compound is an alcohol ether. Okay, now we need to draw the structure of each. Okay, so this is the first structure that we can draw. So we can put this is the alcohol family. So this is the first alcohol that we can draw. A straight line that consists of 4 carbon and the OH attached to the first carbon. Maybe we can draw the second structure. 1, 2, 3, 4, and the OH attached to the second carbon. This is the second possibilities. Okay, so if you can see, this is attached to number 2, this is attached to number 1. And then what happens if we attach to number 3? It will consider as this is carbon number 1 and carbon number 2, and it is similar to structure number 2. So no need to draw that structure lah. Okay. Alright. OH, sorry. And then we try to compress from 4 straight change, we go to 3. Okay, I draw this 1, 2, 3, and we have 1 carbon as a substituent. So this is 1, 2, 3, 4 carbon and OH. Okay, so you can draw the OH like this. So in this case, this is the straight line, this is the straight line. Okay, so this is the line, we have 3 and we have 1 substituent. And can we draw another structure for alcohol using the same change? Maybe we can switch the position of the OH. 1, 2, 3. The CH3 would be here and the OH can be here. Okay. And this is the chain. Okay. Alright, so we can label each structure as A, B, C, D. Maybe I label this as structure A, structure B, structure C, structure D. So remember, for the isomer, we already draw the structure for alcohol. then we will draw the structure for ether. Right now, so we have 4 alcohol, 4 isomers for the alcohol with C4H9OH. Now we want to draw for ether. We have 4 carbon. 4 you can split into 3 plus 1 or 2 plus 2 to become 4. So why I do this? 3 plus 1, ether O must be in the middle and carbon on the left hand side or the right hand side. So let's say we want to do 3 plus 1, 1 carbon here and another 3 carbon here. So this is one ether structure. Right? So if you look at here, this is straight 3. Can we change the chain? So this is attached to the first carbon. Maybe we can change the change. So it attached to 1 and CH3. The difference is this is attached to the first carbon and this is attached to the second carbon. It's still 3. This one is 3 carbon and this one is 1 carbon. 3 plus 1. Can we change it? I think this is the last for 3 plus 1. It's already done. Now we go to 2 plus 2 to become 4. Maybe I can use this pen. O in the middle, 2 here and 2 here. Okay, and this is structure. The previous one A, B, C, D, and then we can continue E, F, G. Okay, now can you name a pair of chain isomer for the alcohol? Alright. For the alcohol, if you want to identify a pair of chain isomer, maybe A and C. It is an example of chain isomer because A is a straight chain while C with one branch, or A and D, a straight chain with carbon with one branch. An example of positional isomer, between it have the same chain but the different position of the isomer. So the example of positional isomer can be A and B. And also C and D is an example of positional isomer. And what about the functional group isomer? Functional group isomer is between one alcohol and another one is ether. So we can put A and E is an example of functional group isomer. Alright, and also we can take any alcohol and one ether as a pair of functional group isomer. So I hope this video will help you on how to identify the isomer. Okay, so this is an example of constitutional or the structural isomer, where it can be divided into chain isomer, positional isomer, or the functional group isomer.